All right, this is lesson 19, evidence, angles, and proof, and it's a cool down called Plead Your Case. In many situations, it's important to understand the reasons why an idea is true. Everybody was getting annoyed with me all day today because I was acting like an annoying little 4-year-old and asking, why? 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 How do you know? Why is that true? How do you know? Because it's important for us to be able to think about, how is it that we know things? Why are things true? How can we prove something to be true? Here's some questions you should ask when trying to convince ourselves or others that a statement is true. How do we know this is true? Would these reasons convince someone who didn't think it was true, assuming they're not just being willfully ignorant? Is this true always or only in certain cases? Can we find any situations where this is false? Because if you can find a situation where it's false, then it's clearly not always true. In this lesson, we reasoned that pairs of vertical angles are always congruent to each other. Remember, vertical angles are these angles that are across from each other when you have lines that cross like this. This is another set of vertical angles, this angle 1 and 2 here. We reasoned that pairs of vertical angles are always congruent to each other. We did this a couple of ways. We saw this by labeling the diagram and making precise arguments having to do with transformations or angle relationships. Not every single class period talked about this in terms of transformations like reflections or rotations, but that is a way that we could prove this. So, taking a look at this, we label the diagram with points. We've got A, B, C, D, and E right here in the middle. Now, keep in mind, when you name an angle, this angle right here is angle A, E, C, or we could actually name it angle C, E, A. And the measure of that angle is y degrees, and the measure of the vertical angle, the one across from it, is z degrees. And again, if our statement about vertical angles is true, then those are congruent to each other. Here's an example of a proof that could show that angle AED and angle CEB are congruent to each other, or BEC. If we rotate the figure 180 degrees around point E, so here's our center of rotation, we rotate this around 180 over here. Then ray EA comes around and ends up over here. And ray ED swings around and ends up over here. This means the rotation takes angle AED into angle BEC, and so angle AED is congruent to angle BEC. We could also do this in terms of a reflection. Mirror images across from each other. Many true statements have multiple explanations. Another line of reasoning uses angle relationships. Remember, angle AEC and CEB form a linear pair because they form a straight line. Now, a straight line has an angle measure of 180 degrees. Why? How do I know? Because we've decided as a society that a full circle is 360. A straight line is half of that, which is 180 degrees. So if a straight line is 180 degrees, that means that this angle and this angle should add up to 180, but that also means that this angle and this angle should add up to 180. So if W plus Y equals 180 and Y plus X is equal to 180. Well, what does that tell us about X and W? That's another way we could prove it. We can do some more algebra-y stuff down there. Anyway, there's a few different ways we can prove this. And what I want you to do for your cool down is plead your case. Give the most convincing explanation you can for why A degrees is equal to C degrees. What's the most convincing explanation for why these two angles, these vertical angles, are congruent to each other? You can use one that I just mentioned, Or if there's another one that makes sense to you, use that one. Let me know if you have any questions.